you speaking into the right microphone? You might be kind of away from the mic or something.
Recording.
Okay.
Yeah, I'm speaking into the correct microphone.
Okay.
I cannot see the slides.
Ines, do you have a headset or are you on loudspeaker? There's a little gargling going on when Michael speaks, which could be your end feeding back.
Can you hear me now? I
don't hear any goggling, but seems the sound to me. Seems the same to me.
Can you hear me?
Yes, I can hear you, Ines. Your sound is clear, not very loud, but clear. And Michael's sound is not very clear.
Not very clear.
And a bit lower in terms of volume.
You want me louder? How about now?
Yeah, now it's louder. It's still not clear. There's this little gargling effect, but we can bear with it.
Sorry.
Okay.
Okay, Charlie, is that any better in terms of audio? Can you either type in the chat or speak to us? Hi, Alvaro.
Hi, Alvaro.
Hey, guys. Good morning. Or good afternoon.
Good afternoon.
Indeed. Good morning to you.
Charlie said that it's about the same, a little better. Okay.
I think the overall volume is low. I am maxed out at all the output volumes. But yeah. I don't know if you can do anything about it.
I think, well, I think I can speak loud. So,
okay.
Should we start the meeting?
I think so.
Okay.
Do we have, Pascal's not there yet?
No. And Conrad neither?
Conrad said something, yeah. I have the laptop next to my chin and me to go all the way up.
I can hear you very well, Dominique and Michael and Alvaro.
Yes, same here, except that the volume is all the way up, which is not the way it should be.
Hello, Charlie?
Yes, can you hear me?
Yes.
Oh, yes.
Okay.
Loud and clear.
Thank you. I will mute again.
Okay, thank you.
Okay, Conrad's just joined.
Okay, Pascal is not yet. But I think we can start with the introduction because I think Charlie needs to leave soon.
Okay, let's get started.
Okay, great. Okay, welcome everyone to this IETF-ROLL interim meeting. Next slide. This meeting, can I have control or, yeah. Okay, let me see.
I can flip the slides.
Okay. Okay, this meeting is aligned with it not well. The next slide. So we will not read it, but be aware of these topics. Next slide. Okay, the meeting materials. Please volunteer for the minutes takers. You can find the link on the top right corner. Next slide. Okay, this is our agenda. We're going to have a working group status. Then Charlie will present the advance in Odb Ripple. Then Pascal will present our projection, which is working group as called. And then Conrad will present Rnfd, how we can continue this work, and then we have an open floor. Next slide. Okay. State of the active internet draft. NSA is in progress with this AD evaluation, and they're working into the addressing the open issues. Then Aodb Ripple, we are going to was back to the working group. We are going to have short discussions today. DAO projection, we are going to have a discussion today, and it's currently, well, in the working group last call, we have not got any input on that, but we would like to know your opinion. And then enrollment priority, I think there are open issues, and it's okay, it will not be discussed today, but well, discussed today, like in the term of there are open issues in GitHub, and I think there are some items in the mailing list as well that need to be addressed to continue this work. MOPEX and capabilities were expired, but yes, we need to have it as a next working topic. Storing rock acknowledge. We want to go for working group adoption of this item, if you agree. And then we will discuss as well how to proceed with the fast border router crash detection in Ripple. And this is the new work adopted by the working group. Then we have inactive internet draft, these modifications, and the VR multicast that they are sleeping, but they should as well. We need to decide what to do with this. Next slide. And then the milestones were updated. We have as initial submission of DAO projection for May, so we are a bit delayed with this. Enrollment priority for September. MOPEX capability, well, MOPEX for November. Capabilities should be for June. Fast border router crash detections, November. This modification, Jan for MPL and multicast, November as well. And in November, we should recharter or closed.
Basically, November is a horizon, so whatever is below the horizon is November.
Yeah, I don't know. Maybe we should update as well with this version 2 of Ripple as this, but yeah, we can discuss that later. Next slide, please. Oh, okay. Sorry for the resolution, but we have open tickets in enrollment priority, Aodb Ripple. I think Charlie is working to closing those issues. A new version 14 was supposed to address all these tickets. Next slide. Ripple observations, just we have tickets to know what to work on. And the MOPEX, we have one ticket open on that. And then additionally, we will have in the IETF 114 a meeting for roll of 1 hour. So far is Thursday on UTC time, 8 p.m. And then we will have on Friday a joint meeting with the Manet, Babel, and Roll to discuss about multicast. There is no specific agenda or problem statement yet, but we would like to basically discuss how we handle the multicast in the different working groups, and if we can maybe rise to work items, joint work items. But yeah, that is to be defined. Of 2 hours. Yes.
Yeah, so Ines is going to be remote for this IETF. I'm going to be local if everything works well. I was allowed to fly over there. Michael, I understand you will be there as well. Is that correct?
I will be there.
Okay, very good. Among the key participants, can we show a raise of hands? Pascal and Charlie, Conrad, who
I will
plans
not
to be there?
IETF. I'm sorry for this. I did not get funding for coming this time.
Okay. But you'll be remote, right?
It's the middle of the night, so if we can arrange things at this meeting, that will help. Because it's very late. I looked at the agenda. If we keep the current agenda, it's going to be very late.
Okay.
I'm on holidays that time. Sorry, guys. During IETF this year, I didn't have any other date that I could choose from. So that particular week, I think I'm on holidays.
Okay, fair enough. At least we know. Thank you. And
Okay.
Charlie,
Charlie?
if we may ask.
Can you hear me?
We do, we can.
Okay, good.
Do you plan on attending IETF 114?
Well, I didn't make a plan yet.
Okay.
I noticed, though, that you were just speaking about roll and Babel and with Manet. And so, of course, they seem to be closely related. Is there a preferred course forward for those?
I'm not sure I understood your question.
Well, I mean, I can imagine that, for instance, Babel and Manet would join together, or Babel and Roll would join together, or Roll and Manet would join together, or something like that.
This is a joint meeting, not a joint working group so far. We're not talking about fusing the working groups together. We're talking about having a joint meeting to discuss the way multicast is handled in those various groups.
You know, I've had sort of a lot of involvement with Manet, and well, Babel was an interesting story from long ago. I might try to show up for the meeting just to see what happens, but I don't have any plans for presentation other than if more revision is needed for Aodb Ripple.
Okay, thank you. It was just out of curiosity, you know, who I would meet in the corridors and if it was a good time to do some side work, hallway work on the side of the actual sessions, but no pressure.
Okay, well, no pressure, thank you. But since I'm not on anybody's payroll, I'm not too much likely to buy a cross-country round-trip ticket and pay for the hotel myself.
Okay, fair enough. I can totally understand. Thank you.
Okay, thank you very much. Yeah. Oh, Charlie, you can continue.
Sure, thank you. Well, first of all, I'm Charles Perkins, and I have been making revisions to the Aodb Ripple proposed standard for roll, and some of the over the last year or so, there's been some delays in my participation, and so now I think finally we're getting towards the end. We had some really excellent reviews earlier this year by March or so, and those caused a lot of detailed thinking about how best to resolve the questions that were raised in the comment sections. And so so this last draft, draft 14, was submitted just a few days ago, but after discussion on presentations of comment resolutions on the mailing list. And so so this presentation is to explain the resolutions for the comments, and also to request going back to last call under my belief that the comments have been resolved. So next slide, please. Or do I have a way to call for the next slide, or do I just ask you for it? Okay, good, slide control. So I'll try that. So 3, 4, 5. By the way, it seems to me that Meet Echo works pretty darn well. Okay, so here is a quick overview of Aodb Ripple. I won't spend a whole long time on this draft, but I think it's useful for reference purposes, and I made a few updates. This slide came from well over a year ago during an IETF presentation, but I made just some very minor updates. But basically, what it shows is that it route request and route reply are now Ripple options, and when they are disseminated through the network, they create two DODAGs. One's rooted at the originating node or origin node, and the other one is rooted at the target node or targ node. And Aodb can create asymmetric and symmetric routes both. And one fairly major change recently was that a new multicast group has been requested, all Aodb Ripple nodes. It used to just use all Ripple nodes, but there was, turns out that the Ripple specification does something that I didn't expect, and it that required that we get a new multicast group. So the route request is sent out by orange node, and then it eventually, as every intermediate node that receives the route request has a route to the originating node or org node. So when it gets to the targ node, then targ node has a route to originating node, but the intermediate nodes don't necessarily have a route to targ node. And so it sends out the route reply to advertise itself, and that is passed along. And when it gets back to origin node, maybe by a different route, then there's routes in both directions, and the DODAGs are set up. So, so that I guess is a pretty short explanation of the protocol. And there's one other feature that was adopted from Aodb that was developed in Manet, and this is called gratuitous RREP. And basically, the idea there is that if a route request gets to an intermediate node, let's just say that one, and that one already has a nice symmetric route to the targ node, then it can advertise back already, and their originating node will get the route reply faster, so it can start transmitting data to targ node. However, as was in the point of discussion on the mailing list and in comments submitted, that does not necessarily mean that org node, it does not mean that the originating node has the instance ID of the DODAG that's rooted at targ node. And so that required some careful explanation in the draft, which has been done. All right, so next slide. Unless there's any questions, I guess anybody can just stop me. But I wanted to put in this information about the IPv6 Ripple option, because this is really crucial for data. So first of all, local instance ID, the Ripple instance IDs that are used by Aodb Ripple are local Ripple instance IDs. And when org node has, so first of all, it's a little bit of I was a little originally confused, because it turns out that the instance ID does not uniquely identify the instance. And so the name is not correct. I mean, if it's an instance ID, then it should identify the instance, but it doesn't. It's required for local instance IDs to be combined with the IP address of the node at which the instance is rooted. And in the case of the RREC instance, that's rooted at the orig node. So I made some definitions for route request instance ID and route reply instance ID, which really is the instance ID when in an ordered pair with the IP address of the root node.
Charlie, we have Pascal in the queue, I guess, is trying to ask a question.
Yeah, I
Sure.
just wanted to say, when you have an identificator, an ID, it has a domain in which it is effectively identifying something. And a local instance ID is unique within the domain of the local source node or destination node in the packet. So it's still an ID. It's just that you're assuming that any ID is global. It's not. I mean, this one is local by name.
Well, I understand, Pascal, but I'm just saying that somebody that didn't read every word, they might assume that an instance ID identifies the instance, and for my purposes, it did not. But I do understand what you're saying. Okay, so one thing about the instance IDs is that the originating node needs to pair its instance that's rooted at the orig node with the route reply instance that's rooted at the targ node. And when it does that, when it pairs that, then it doesn't have to continue with the route discovery because it's got the routes in both directions. And one factor that has to be accounted for is that it is theoretically possible, although I would hope it doesn't happen all the time, but it's possible that you might need two routes between originating node and target node that have different objective functions. So that means that we have to be very careful about the pairing between the route request and the route reply. And since, as Pascal just noted, that the instance IDs have local scope, it is possible that when targ node, we'll go back just a second, it's possible that when targ node receives the route request, that it's already used that instance ID for something else, and so it needs to assign a new instance ID for the route reply instance. And since it's no longer the same as the original instance ID, we have a mechanism called the delta field. And so that allows the original to pair the incoming route reply in instance ID with which route request that it had issued to discover the route. So that's and when that happens, when targ node and orig node both have the DODAGs available, then they can send out packets with D equals 0 and using the instance ID, their local instance ID for data that they want to send. So that, what can I say? I didn't fully understand all of that until maybe a few months ago. So I thought I'd try to explain it in this presentation. Okay. All right, so then I made a relatively complete list of all the changes from the last draft until version 14, which was just sent out a few days ago. And there was some discussion about the claim was made that Odb Ripple is a natural choice for a routing protocol in some circumstances. So I put in language into the draft describing about the scenarios that would lead one to choose Aodb Ripple. And there was suggested to include some informative references, which this suggestion was much appreciated, that describe the value that's provided by peer-to-peer routing. And then we requested a new protocol, a new multicast group. And I want to explain a little bit about this. The original design of Aodb Ripple, we thought that it would be just fine just to have some different option numbers assigned to the route request and route reply option and the ART option. And then since the option numbers would not be recognized by the intermediate nodes that didn't implement Aodb Ripple, that since they didn't recognize them, they just wouldn't process them and drop them. But turns out that Ripple specifies that you don't drop them, you just send them on. And so from my understanding, it's difficult for me to really imagine a reliable operation of AODV if an intermediate node that's unaware of the purpose of it would just forward it to the same multicast group. So that basically would break the protocol. And in order to maintain the correct operation of the protocol in the face of this specification from base Ripple, I think it's just, it works if you make a new multicast group. So I have to admit, though, I was surprised about that part of the Ripple specification. Well, it's a simple matter of citing the base specification as origination of the definition of DIO, but wanted to include that in the terminology so people wouldn't have to be flipping back and forth to previous documents too much. We use the terminology hop by hop route, and that's not terminology from the base RFC 6550. So needed a definition to say that these hop by hop routes are the ones that are created and use storing mode of Ripple, which is pretty intuitive. There was a discussion about, Aodb Ripple basically specifies that when you exit a DODAG, then you're just not routing on that DODAG anymore. But it turns out that shouldn't be considered a permanent thing because, 8 months from now, maybe they use the same instance ID and it creates another DODAG that has the same Ripple instance ID. And so you have to be able to rejoin a DODAG that has the same instance ID. And so for that purpose, define a new configuration variable that after that has elapsed, the node is allowed to rejoin DODAG with the same instance ID. So that was just sort of an oversight on the original specification. I mentioned before that I created some terminology for route request instance ID and route reply instance ID. These are, I'm sure, quite non-controversial, and so, but they make the document more accurate to use that terminology. Oops, wait a minute. Okay, continued. Okay, so it was noted that the terminology in the Aodb Ripple document said it had a complete source route. Well, in a way, that's not really true. It just has the addresses in the address vector that are needed to go from hop by hop back from the source to the destination. So that's all we needed to say, and we didn't need to say complete, so I changed the definition of source routing for that. And then there's a figure 4 shows the border router, and that without any further description, it is illustrative, but it might give somebody the impression that Aodb requires a border router, which it does not. So I explicitly put in language that the figure does not imply that Aodb requires a border router. There was some discussion about how do you select a value for the L field, and so I put that just almost directly from the discussion on the mailing list. And so for storing mode, it's pretty easy to imagine that people or the routers keep track of the next hop information and so on, and the rank. But for non-story mode, so the route request instance is a data structure that's maintained by intermediate nodes so that they have information about routing back to the origin node. And so so then if we did not say that the intermediate nodes had to keep track of the address vector for non-storing mode, but if they don't keep track of the address vector, then they don't necessarily have an easy way to make use of the symmetric route back to the org node. Oh yes, and another important point for nodes that have multiple interfaces, the address of the interface that the route request comes in on is possibly different than the address of the interface that the route reply comes in on, and so both of those are needed for getting the address vector correct. It was requested that we produce some interesting reading material for details about evaluating link asymmetry. There's many different ways that links can be asymmetric, and determining that is in some cases non-trivial. It's not within the scope of the Aodb specification to specify how you evaluate the asymmetry, but there is it's an implementation detail that is important. And then lastly, I used the route request instance ID and route reply instance ID and some additional language in the gratuitous route reply subsection to clarify the details, and I think it's much clearer now. So that the last round of comments, as I mentioned, came in around last March, and caused a lot of very detailed analysis on our part for the protocol, and that the final analysis turned out to be very beneficial for clarifying parts of the specification, and so it's much appreciated, and we're still looking for additional review for draft revision number 14. But as of this moment, I believe that all the issues have been resolved, and as Inez mentioned, I plan to go into GitHub and make that and actually resolve the issues there. So so I believe the document's in really good shape and ready for last call. And I guess that's the end of my presentation.
Thank you, Charlie. Very informative presentation, and it's good to see all the work that has been done on the document in the recent weeks. I know there are a few people who said they would need some time to respond, namely Conrad said he would need some time to check your responses and respond back if needed. But given some time, I think we can converge on this. Any comment from the audience? I see no hands shown. Okay, thank you. So,
Well,
yep.
Yes, so I just wanted to mention that I'm not likely to stay on this call for very long because we're going to the airport today, and it's a busy time. So I think I will drop off the call, but I am very happy to receive any questions or comments by email, and I look forward to going to last call whenever we can.
Thank you very much, and thank you for taking the time to join this call. Very much appreciate it.
Well, you're very welcome.
Okay, so how do I get control back?
The box slides.
Okay, let's share again. Pascal, are you ready?
Yes, yes. So you're presenting, right? Or do you want me to share?
I can pass control to you. Here you go.
Okay, neat. So yeah, so this is about the projected DAO draft, which is called root initiated routing state. It really means that the root is in control of establishing outside TE path inside the Ripple domain. Now, it might be that the root is doing that on behalf of a controller of any sort, but we are using Ripple and a very similar protocol to normal Ripple operations. So it's certainly the piece that is being controlled by this RFC and this draft is only the Ripple piece, and whatever happens between that controller and the Ripple root is not the subject. So as a reminder, the different objects that we are manipulating, there are two main objects. One of them is what we call a track, and the track is a non-storing dotted line multipath. So it's a DODAG, but expressed as non-strict source routing, so it's dotted line. And the hops between two dots in the dotted line are a segment. And the segment must be fully strict. So basically, you can see it as a skeleton that is built using non-storing. And then the lines between the skeleton are installed as segments, which are storing. And this applies to the main DODAG, which is expected to be non-storing. And we need that because we need more topology information at the root, which is available in non-storing mode, but not available in storing mode. So we expect the main DODAG to be non-storing. And we can already make that main DODAG, quote unquote, dotted line, so that in the source route header, you have just a loose indication of the hops, in which case you already need segments, but for this main DODAG. So that's one way of using the draft to basically enable to compress the source routing header in non-storing mode by installing very local storing mode segments, which would basically complete the dots. The other way to use it is to install, I would call that overlays. So local DODAGs, if you like. So it's not AODV, it's another way of installing them. These are DODAGs that are within the main DODAG, just for a shortcut between A and B, quote unquote. And so again, you can use it, you can use non-storing mode to install the track, so the dotted line multipath, and then complete the dotted line with source with storing mode segments. So this is pretty much what we show in here. The signaling is very, very similar to the normal Ripple. A track, which is not the main DODAG, is still a Ripple instance. It's just a local instance, which is owned by the ingress. But once you're inside this instance, this overlay, you can figure that it's mostly the Ripple operation as you know them, which happen. So I listed there a number of rules that I already presented. In interest of time, we won't go through all of them, but basically non-storing mode to build a track, it's the loose DODAG, and then storing mode to install the segments between the dots. So we had quite a bit of reviews on this draft. So the first very big review was the one by Torles on draft 21. And that caused us, to help a reader which is not really aware of what we've done. We basically reorganized the document quite a bit, and that was the biggest of Torres comments. Obviously, there were technical comments, etc. But the big thing he told us is, oh, please make it more readable for somebody who is not really within the group all the time. And so do things in a certain order so people who read serially from beginning to end can understand. So we did that, and we moved a lot of examples earlier in the document, so you know what to expect when you go to the gory details. Then there was Michael's review. Thank you so much, Michael. I see you're here. Then 2 drafts actually to handle Lee's review. And finally, we got Remus Harris' review, which is the one that was not yet presented at the ROLL meeting. So I have a little bit more details. A lot of what he asked was clarification. And so we explained that a track is an overlay. We explained that what you find in the VI information option, the VI information option is the equivalent of the transit, but with multi-hop. So when you install this track or the segments, you need to install multiple hops. So the messaging is still a DAO, it's a projected DAO, but instead of having just a non-storing TIO to transit information option, then you get a VIA. So you can see it as a multi-hop transit. It's really a good way of saying it. And finally, Remus provided me the diffs for a number of typos. So thank you so much, Remus, for that. And as the chair said, the document is undergoing workgroup last call. If you've not done your workgroup last call yet, your review, please consider in particular if we're missing status codes, error flows that you would think should be documented, stuff like that, flows that we should document, things like that. And yes, I really welcome more reviews, but I already acknowledged that we had a good number of them. And that's pretty much it, your chairs. I'm very sorry not to be at the IETF. It cost me a lot, just not just ROLL, but as you know, 6 law, we have to handle multicast document between ROLL and 6 law, and I would have liked to be there for that discussion. And many other stuff, actually, but yeah, I won't be there.
Thank you, Pascal. No worries. We'll make good use of the tools to work remotely.
It's a long week, and you can't stay in the middle of the night every day and work during the day. So it's, I can't promise a John. I'm not a late person personally. I have a very hard time to stay awake late. So I really cannot promise.
Yeah, never mind. When I said remotely, it didn't mean synchronous. It can be asynchronous using emails or stuff. So don't worry. Any comments on this draft? Anybody that is willing to provide a review and didn't have time to do it so far, but is planning on doing one? So we need to know what's coming up. Conrad, go ahead. Oops.
Yes, Conrad.
Yeah.
Okay. When would you expect this review to arrive? Because I could provide a review, but probably somewhere late summer. Would it be okay, or is it too late already?
What is late summer?
Like second half of September. Sorry. Yeah, just asking if it's too late. Then
a review is always good, Conrad. For the one thing, even if we're in the ISG space, I mean, you can always put a review to the mailing list. But I don't believe that we can hold the document for 3 months. It doesn't mean that we not account for your review. Please review the latest, which is published. When we go through ISG, what I do usually is I publish every time I get reviews. So the next reviewer will always review based on the previous reviewer's work. So I don't hold the document. I republish, bang, 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 bang. And so if the day you want to review, just pick the latest one. And if you have questions, please use the mailing list, and I will appreciate Anyway.
Okay, then if I find time, then that would be a late summer, if nothing pops up. I mean, nothing else. Okay.
Right.
That's
Yeah, I concur. I think we want to submit to ASG before that, but again, it's not done once we've submitted to ASG, so review is still welcome. Thank you so much for volunteering.
okay.
Okay, Conrad, it says your turn to present when the slides are.
So,
And in the meantime, about the 6-law multicast document is going to be deal in the 6-law, but it's going to be as well last call shared with roll. So have to pass roll approbation basically to be able to be published. So just be have in consideration this, that we're going to do like joint working group last call for 6-law multicast. Thank you. Okay, Conrad.
okay, so sorry for my voice. I'm hopefully recovering from some illness, but sorry. So I would like to present this draft about Rnfd, which is about border router detection. It has been recently adopted, by recently, I mean somewhere like February, end of February, beginning of March. So basically, the aim of my presentation is just to sort of remind what problem this protocol solves and what the proposed solution is, and try to inspire some new discussion. Well, okay, that works. So first of all, why consider LBR crashes? They play central role in low power and lossy networks. They are DODA routes typically. The hardware that is used and also the software is typically more involved than that of a constrained node, and usually they require a tether power supply, which is hard to provision in many deployments, at least from my experience. So how does handling a DODAC route look like? So we have a DODAC here. We have like the preferred parents that are indicated by arrows and alternative, say, links, which indicate neighbors, which are the dashed lines. The nodes are assigned ranks and so on. So whenever a border router fails, what happens is that in practice, all links to this border router from this border router are down as well. So in Ripple, we don't have like an explicit node failure detection. So in fact, nodes rely on neighbor discovery to detect failures of individual links. So in order to handle this failure, the nodes have to detect that all the links to the route have failed. And in principle, they have to adopt infinite ranks, which means that they are unable to reach the border router, the DODAC route, and drop any parents because there is no structure that would lead to the DODAC route. What happens in practice? So if you take a look at implementations, open source ones, so some of them have still major bugs, and upon a failure of a DODAC route, they enter some chaotic state with an explosion of control traffic. Some are better in the sense that they may not detect bugs, but at least the protocol doesn't get in any worse state than it was before the failure. And some are correct, but in fact, Ripple correctly handles DODAC route, assuming that it has like a working neighbor discovery protocol. But this procedure takes time and traffic. And it happens because all links to the depth border router have to be detected. Even if there is one link that is considered to be up, and then the neighbor will advertise a path to the border router, and other nodes may choose this neighbor as an ancestor in the DODAC, which means that you still have some route advertised. Another problem is that the detection of crashed links is typically reactive to save traffic, energy, whatever. So this means that it may take a while. In principle, you have to use that link in order to detect that it has failed, has crashed. And learning that actually all links to the root are down is also slow because what happens is that the nodes will try to do local repair, so they will try to switch parents and so on. In the process, because they have inconsistent knowledge, some loops can be formed. So you will have many trickle timer resets, and all these, let's say, this emergent behaviors, they contribute to the latency of detecting the crash of a DODA root. So what is Rnfd? It's a root node failure detector. It's an additional algorithm that works in parallel to Ripple. Its goal is to minimize time and traffic of detecting a crash of an LBR. And some measurements that we made. The latency is reduced even by an order of magnitude, and traffic, including data traffic and control traffic, can be a fewer times less. So what are the main design principles? So first of all, the detection of the monitoring of links between constraint nodes and border router is coordinated. Probing all links is avoided, which means that if sufficiently many links are observed to be down, then a conclusion is made that the root must be down without probing some other links. This is to avoid some long tail of detection. Then proactive checking of links can also be triggered when the situation changes, and the protocol, the algorithm in general, tries to maximize independence of Ripple. So this was the original goal. So it may be questioned, but this was the original goal. So the basic idea is that there are two types of nodes, so sentinels, that they are some of the root's neighbors, can be all selected ones that basically monitor the status of the link to the root, and acceptors are any other nodes in the algorithm. So here you can see that these are the possible sentinels. Not all of them have to actually be sentinels. And the algorithm, just from a very high level perspective, works in a way that individual sentinels detect crashes of the links to the DODA root. And then they exchange this information in a new option. It's Rnfd option through this link local Ripple messages, so mainly dials, possibly DISs. And then based on the number of sentinels that believe their links to the root to be down, a consensus is made that the root has crashed. So the main problem that Rnfd solves is how to make essentially this consensus. So what's the status of the draft? So it was adopted by the working group, as I said, at the end of February, beginning of March. Two notes, two things to note actually. One was the conclusion was that the topic was important, border router crashes. But then the solution need not be the final one. So Rnfd need not be the final solution, or it has to be modified. That was the conclusion, that we don't, let's say, preclude any changes to the protocol. So it may be changed. So my question is now how it should be changed, if at all, or how to approach making the protocol mature. Michael made a suggestion that we could adopt the draft as is, as experimental draft, and perhaps work on this later. And Pascal earlier had some remarks about using the DODA root itself for, in fact, monitoring itself. So we could talk about this more. But well, I could also use feedback from other people. So so basically, this call is also to somehow advertise the draft so that other people could join, and contributors are welcome. So I'm pretty open to that. So that's it on my side. I'm on time.
Michael, I see you raised hand, so probably you want to comment.
clarify my suggestion. The document is already adopted as the working group document, but I'm saying when we publish it as an RFC, that we may get a little less friction if we go through as an experimental. And I think that, well, I think that's just a useful thing to say. This is an interesting thing. Whether or not it proves to be useful in the field is the point. But I'm just saying that may be a little bit of a lower friction way to publish. Not that I think the work is unfinished, but I think it just may be easier to go that way. But that's really up to the working group to decide and the AD.
Thank you for the clarification. Pascal, do you want to comment on your remark?
Well, we really would need a whiteboard, but it might be that the network is non-broadcast between different first hop devices from the root. In which case, it might be that it might even, the worst case, it's a hub and spoke thing where none of the first hops see any other first hop. And so it's very hard for them to get to a Byzantine general agreement if they don't see enough of the peers to make any decision.
Yes, but can I interrupt, Pascal?
Please go ahead.
But the decision is made not by the first hops; it's made by the other nodes. So if there is any path between this first hops, so for instance, you have a star that is somehow connected at the very, let's say, edges, then you will still have consensus. So only if you have like really disjoint paths, disjoint subtrees, essentially disjoint networks whose only connection is the DODAC root, then this algorithm won't work. But well, then you have to rely on Ripple itself, which is probably not bad in this case, because since there is only one path, then it is very likely that the failure will be detected fast.
Yeah, so what if most of the DODAG loses connection to the root, but some of it still retains? And at some point, Ripple would fix that. But is it possible that this work kills the DODAG even if the root is still there? Like
yeah, if there is just one connection, so this is just a probabilistic algorithm, right? So if you have like, say, 1,000 nodes and say 1,000 one-hop neighbors or 100 one-hop neighbors, and just one neighbor has a link to the DODAC root, then yeah, this algorithm will actually kill the DODAC. But I would argue that this case is quite desirable because if, let's say, 99% of let's say root's former children lost their links to the root, then the DODAC should probably be reconstructed from scratch because it looks now completely differently. So killing it and issuing a new DODAC version, because in the protocol the DODAC root would notice that it's alive and has some link to some other node, so it will introduce some new DODAC version, and the new DODAC version will be built hopefully according to the new links. So I would say that this is a desirable situation. Like if 90, let's say 50% of your links failed to the DODAC root, then probably your DODAC should look completely differently at this point.
I mean, yeah, it makes sense. I'm just trying to shake the design for race conditions.
Yeah, I appreciate that.
And like, you know, as if the first hop can talk to one another and see that the root is still there, even if their children think it's not. I mean, if they can still talk through the root, it means the root is still there. So it's like it's like deciding that somebody is dead without asking him. And if you ask the guy, "Are you dead?" and he says no, well, that's probably true.
No, but okay. So 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 now the situation is as follows: that two guys can talk through the DODAC root, right? But they don't. That they are unable to reach each other, or what's the scenario?
Yeah, the scenario is some nodes down the Aodb cannot reach the root for some reason, or they think they can't. But maybe it has been restored up there or whatever. But the first hop nodes, they can talk to one another via the root, and so they can basically ping one another via the root. And so they are kind of monitoring implicitly that the root is still alive because they kind of ping one another. And so if below them their children tell them the root is dead, well, they would say,
well, but what if the children would so the children can only tell them that the root is dead based on their own observation, or say their peers. So this means that sufficiently many of these one hops don't actually see the root. And in this case, what happens is that if you can talk to the root, then through the root, then the root will also see those guys that can probably see him, and it will also receive information that many nodes consider.
Makes sense, Conrad. I'm still, it's still the decision by some to kill something else. So it's a dangerous decision. So I'm really trying to shake it because that would be unpredictable.
No, the problem is that they won't kill it. So if the root notices that something, let's say, fishy happens, then it can react. Like, okay, I will just rebuild the Dodak with a new version.
Exactly.
Yeah.
Okay.
Okay.
Sorry, guys. I need to do my chair work, and so we are over time. What I gather is that we have food for thoughts for further technical discussions. I'd love to be able to discuss live. However, I understand the IETF-114 is not going to be the right opportunity for that. So let's try to have this discussion on the mailing list as much as possible. And then we have an interim meeting that will take place end of August or early September, probably. So let's try to advance that technical discussion so that we converge on that. Ines, any other suggestion?
Yeah, I agree with that. I think it's an interesting topic for the mailing list, and even if the presenters cannot be into the IETF, we just can raise the topic if some additional people can comment on this when we decide that the Dodak is hash, even when they have connections with another sentinels. So yeah, it's good topic. And yes, I think the interim could be in September or after summer, so people can take vacations.
And it will be probably in a time zone that fits most participants. We had open floor on the agenda within 10 seconds. Any pressing issue that needs to be mentioned? Going once, going twice. No pressing issue, so the meeting is over. Thank you very much for joining.
Thank you very much.
And hope to see you at Philadelphia for those who can go or can attend remotely, and otherwise on the mailing list. Thank you for the good work. I saw very good progress. Thanks a lot.
Thank you. Bye-bye.
Bye-bye.